Hello everyone, welcome to Basic Fire Protection Design course. In this topic, we will study water riser system. Before we study what is a water riser system, let's look at this drain riser schematic. We know what is a drain riser system. It is just a particular empty pipe. So, to this drain riser system, we remove this bridging inlet, and then we try to connect permanent water supply from the tap and pumps that connect to their particular drain riser pipe. So this pipe beacon, how many would this pipe beacon will there? How many water supply? So this is the convolutional drain riser system to water riser system. What is a water riser? A water riser is a fixed installation of water supply pipes in the building that are permanently charged with water so that high floors will always have immediate access to water supply in case of fire. These are the main components of a water riser system. We will have water tank, water riser pump, duty and standby, and jockey pump to pressurize the whole system all the time, and pump control panels, and landing valves, standby fire hose, air release valves, bridging inlet, and water riser pipe. This is a photo of a water riser system in water riser pump room. According to fire code, water risers are said to be provided in buildings or habitable height more than 60 meters. If the building habitable is less than 60, we can provide ground riser. If the building habitable height is more than 60 meters, then we have to go by water riser system. Sometimes we call downcomers, especially for HDB building in Singapore. The water riser story that is located on the roof. So water supply is from the higher floor to lower floors. In that case, we call water riser as the downcomers. For the design of water riser system, we have to base 1, access by 7.5, Kudo British for fire hydrant, rising mains, and hose-free systems. As per the code, when 3 landing bars are in operation, we need to achieve minimum 27 liters per second for a residential building and 30 liters per second for a non-residential building or any other mixed occupancy building. Based on this table 3.2, we have different query requirements for different number of steps. For example, inability, if there is only one step, water riser system for a residential building, step 1 must be minimum 30 liters per second flow rate, or residential building minimum 27 liters per second. And the pressure of the pump, a minimum running pressure of 3.5 bar and a maximum of 5.5 bar shall be maintained at each landing valve when any number up to 3 are fully open. So this means 3 bars are up in operation. The minimum pressure at this point must be 3 bar. And for the landing valve, which is the nearest to the pump, the pressure may be more than 5.5. For that case, you can use PRV, pressure reducing valve. It can be installed at the landing valve if the pressure is more than 5.5 bars. And other requirement. Rising mains and downcomer shall be electrically arc drains, which do not provide electric equilibrium shall be bounded. And once the rising main is situated in the vicinity of any lightning conductor, it should also be bonded to the lightning conductor in accordance with AS 555. Okay, let's look at this. Water riser pump selection for a 20-story residential building. In this schematic, this is a water riser schematic diagram for a 20-story residential building. There are 2 water riser step pipes. So for the pump floor right, it is a residential building. 2 stacks. So we can go to the residential column in table 3.2. There are 2 number of stacks here. Then for the residential building, we need to achieve minimum 40 liters per second of the flow rate. For the pump hat, you need to correctly base on the ability, steady height, and vibration loss as explained in previous stop it. To achieve minimum 3.5 bars at all and above. For the tank capacity, pour 30-minute stories, pour 2 stocks. Mini-mat, story capacity is 72.9 meter cube. Let's look at a Grenfell Tower desert start happened on 14 June 2017 in London.
A catalogue of safety breaches at Grenfell Tower contributed to the rapid spread of the fire. That's according to experts testifying at the Grenfell Tower inquiry.
I have never seen a building where the whole of it was on fire. Nobody has ever seen that. It was incredible. It was so alien to anything I had ever seen.
The blaze started in flat 16 on the 4th floor of the east elevation. It rapidly spread through the window. The first image of the flames taking hold outside flat 16 was taken at 1:09 a.m. It took just a few minutes for the fire to spread up 19 stories to the top of the building. While the fire was spreading upwards, it was also spreading horizontally at a tremendous rate, and in opposite directions, until all 4 elevations of the building were engulfed in flames. The flames met at levels 22 and 23 near the southeast corner of the building. In total, 98 flats were exposed to the flames. 72 people lost their lives in the tragedy. The report identified the cladding as the primary cause of the fire spreading up the outside of the building. Tests showed the cladding materials didn't comply with the recommended fire performance for a building of that height. It also claimed the key players involved in the 2016 refurbishment of the tower hadn't found out how the new cladding system would behave in a fire. Other safety breaches were cited for the devastating spread of the flames. The windows lacked fire-resisting cavity barriers and were surrounded by combustible material. That meant there was a high probability of fire spreading to the cladding. Poorly performing fire doors contributed significantly to the spread of smoke and fire to the lobbies. And some doors failed to self-close after an occupant escaped. This allowed immediate spread of fire and smoke. Lastly, firefighters may have contributed to the spread of fire and smoke into the stairwell by leaving doors ajar as they fought the blaze. Many more questions still need answering as to how a small domestic fire spread so rapidly and so catastrophically.
After watching this video clip, we understand that fire and protection systems are very critical for residents of the building. As indicated here, firefighters can put out the fire only at low level by using fire engines. For the upper floor, they cannot put out the fire. So this is one of the reasons wood riser systems are required for higher floors. All engineers at restaurants were for proper design and installation of fire protection systems in the building. In Way Stop It, we will study the designer automated flying sprinkler system. If you're interested in learning M&A design, don't forget to like and subscribe for more videos.